as we move on to our next examples, I wanted to let you know that after I recorded the original video, I decided to rearrange the foldable a little bit. So in the video, you're going to notice that these are all kind of in one big column, but I kind of squished it in order to fit our final example. So you have the same content, it's just arranged slightly differently. The next examples that we're going to look at are talking about continuously compounded interest. In our last lesson, we learned that interest could be compounded in different intervals. We talked about some examples where it was compounded quarterly, which meant 4 times a year. And then we said that we could have different intervals as well. We could have monthly, weekly, daily, something like that. So whenever we use this version of our compound interest equation, because we have this E here, this is an equation for continuously compounded interest. So interest is constantly being accrued and rolled back into our principal. And that is the powerful thing about E, our Euler number. So let's go ahead and define all of these parts and pieces. A is still our final amount, just like it was for our regular exponential compound interest equation. P is still our initial amount or principal. R is still our rate, and remember that we have to do that as a decimal. And T is time. So the only difference here is instead of having a certain number of intervals n, we are continuously compounding by using the Euler number. So let's use this equation in a couple of examples. And I tell you what, I want to jump to example number 8 first because it's a little more straightforward, and then come back to example 7. So let's go ahead and go down to the bottom of the page to number 8 to start. So if we have $500 to invest at 3%, and we're told that we're continuously compounded, so that should be the clue that we're going to use our natural base compound interest formula. We want to know how much we have in 5 years. So let me remind you of the equation. A is equal to P times E raised to the RT power. So let's go ahead and identify what we know and then figure out what we need to find. So we know that we're starting with $500. So that is our P value. We're investing it at 3%. So 3% is R, but remember, we're going to have to make that into a decimal instead of a percent. We know that we're going to have E, that's our constant right here. That is 2.718, etc. And we want to know how much we have in 5 years. So 5 years will be our T value. So we have everything that we need to find A, how much, at the end of 5 years. Let's go ahead and look at our 3%. And remember that in order to change percent to a decimal, we move it 2 places. So this is going to be 0.03. So we will plug that in to our equation. A is equal to 500 multiplied by E raised to the 0.03 times 5 power. And you can simply put this into your calculator or in Desmos Scientific Calculator. Remember, you don't want to approximate E, you want to actually use the calculator value for E or the Desmos Scientific Calculator for E. So you want to use either the second and division key on your calculator or just simply type a lowercase e in Desmos. All right, and when you do that, what you should come up with is that A is equal to $580.92. Okay, that one's pretty straightforward. Let's go ahead and take a look at number 7. So for number 7, we're told that we need to have $25,000 in 10 years. Maybe parents are saving for college or something. For somebody that's in elementary school, yeah, that's it. And so our final value, the value that we want to have at the end of 10 years, is 25,000. So that's A, not P. We have a 10-year time frame, so T is 10 years. Our rate is 9.8%, which we will change to a decimal, and we're compounded continuously, so we know we are using an E value. We want to know how much we should put away today, so we want to solve for P. We know A, we want to solve for P this time. Let's first go ahead and convert our rate into a decimal, so 9.8%, and we will move 2 decimal places over, and that's going to give me 0.098 as a decimal. So that's what we will use. All right, let's plug in what we know so that we can solve for what we don't know. I know A, 25,000. I don't know P. And then E is my constant. Raise that to the 0.098 times 10 years power. So I need to solve for P. Remember, we already know what E is. That's not a variable, even though it is a letter. I want to solve for P. So in order to solve for P, I need to get rid of E raised to this power. Well, how do I do that? The same way that I would get rid of anything that's multiplied. I would divide by E raised to this power, 0.098 and 10. But if I do it to one side, I also have to do it to the other side. Divide by E raised to the 0.098 times 10. So here's what that's going to do for me. That's going to cancel out this, E raised to that power, and just simply leave me with P on this side. And now what I can do is put this in my calculator. I have 25,000, and then I want to divide that by E raised to the 0.098 times 10 power. Practice this in your calculator or Desmos Scientific Calculator if you're at home. And what you should come up with is a p-value of 9382.78. So in 10 years, we've gone from about $9,400 all the way to $25,000 based on these criteria.